So we didn't talk about these yesterday officially. Some of them were demonstrated. But if you have like addition or subtraction inside of your integral, it's the same thing as doing the integral separately with that addition or subtraction in between. Kind of like we did with derivatives. Okay? Whether you choose to write this down or not is up to you. Okay? Some of you look at this and say, I already knew that, and that's fine. Okay? But then, Nicole, kind of what you were asking about up here, whether there's a constant inside or outside of our integral, it gets treated the same. Okay? We can take the antiderivative and multiply the constant after. Okay? Kind of like our constant rule with derivatives. I always said it goes along for the ride. Same thing here. Just goes along for the ride. Yeah.
6.1 or 4.1?
4. Did I say 6?
Yes.
I don't know why it's 6. It's definitely 4. Yeah. Like to there.
Yeah.
It's 4.1. We're going to continue this. And we'll do more with 4.1 even when we get back from break. But this will help us solidify even some of our derivative concepts, which will help with our final. Okay. And this is your last final. I don't like that for you.
Oh my god. That's crazy.
I dislike it because you are my largest class, and your final is last. You have to have it in my That happens
There
every
could be
year.
like 4 people left here. It's gonna be awkward.
4? 1, I think 3.
Is it 3? All 4 years.
Yeah, I know, it's even worse.
It's just gonna be 5.
So, and this final, out of all the finals, I mean, all my finals are about the same length, but grading this one, I have to pay a little bit closer attention to certain things just because of the calculus stuff that we do. So, it's going to be a grading machine on Friday. Okay, yesterday we talked about this. There is no need for you to write this down. However, if you don't have x to a power in your integral, you would need to rewrite it like we did yesterday. Okay? So in your homework, like this stuff up here on the board, we had the cubed root of x squared in the denominator. We rewrote that to have a negative power, so then we could take the integral. Okay? Same thing's going to happen if we have like multiple terms, maybe divided by something or multiplied by something. We do not have a product rule or a quotient rule for antiderivatives. You have a power rule, and you better be able to work with that power rule. Okay? So if you have something that looks like this, it is not okay. Write it down. But you cannot take this antiderivative right now. Not going to happen. What do we need to do? Okay. This is like x to the negative 2. So whether you write it as a product or we just do the division right now, we need to write this as 4 individual terms. Okay? What is x cubed divided by x squared? minus 5x squared over x squared plus radical x over x squared. So we have x to the 1/2 divided by x squared. 1/2 minus 2 would be negative 3/2. And then we have minus 7x to the negative 2nd. Agree with all that?
Yeah.
Okay. It is possible that you could have a problem like this on your quiz tomorrow. Rewrite it before you take the antiderivative. Okay, so let's use our power rule 4 times. We have x to the first. So that becomes x squared times 1 over 2. Minus 5 times the antiderivative of a constant is that constant times x. Okay? Now we have x to the negative 3/2. We increase that power, it would become negative 1/2. And then we would have to multiply by, okay, I'll rewrite it to make it look prettier. Okay, minus 7 times this power would become negative 1, and we have to multiply by its reciprocal, which is just negative 1. So I'm going to rewrite this to make it look pretty. So 1/2 x squared minus 5x minus 2x to the negative 1/2 plus 7x to the negative first. Don't forget that. Plus c. Questions? Let's talk about trig. We talked about it a little bit yesterday. Okay? My suggestion to you would be to write down what I write down in red. Okay? But let's just think about some things. The derivative of sine is cosine. So the antiderivative of cosine would be regular sine of x. This is where we really have to be careful with our negatives. Okay, my suggestion is to always think about the derivative of your answer, and does that get you back to what's inside the integral symbol? Okay. We know that when we take the derivative of cosine of x, we would get negative sine of x. So the antiderivative of sine of x would be negative cosine of x plus c. That's something that you talked about a little bit in your activity yesterday, correct? I think I remember that happening. Okay. So let's talk about the other 4 rules that we have. The derivative of tangent is secant squared. So the antiderivative of secant squared x is tangent x plus c. The antiderivative of secant of x, you don't even want to go there yet. We don't know it. Very complicated. Okay? But the antiderivative of secant squared, we know is tangent because the derivative of tangent is secant squared. Remember, if you can take this derivative and get back to in here, you're good. All right, the derivative of secant x is secant x tangent x. Therefore, the antiderivative of secant x tangent x
So do we?
take a moment and talk about the other rules that we haven't revealed yet. What are the two rules that we are missing? Oh, you're right. Okay, which two are we missing? Okay, so the derivative of cosecant is negative cosecant cotangent. So if you see cosecant x cotangent x in a derivative, we are going to have to say that the antiderivative is negative cosecant x. Okay. And same thing with the other one you just mentioned. The derivative of cotangent x is negative cosecant squared x. So if cosecant squared is in our integral, our antiderivative would be negative cotangent x. Okay. So your biggest thing here is we just got to keep track of which antiderivative goes with what. Like I said, if you could take the derivative and get back to what's inside the integral, you'll be fine. Okay. So let's talk about a problem very similar to what we did yesterday. Okay. You had one almost exactly like this on your Brain 1, Brain 2 sheet. So feel free to write down what you think it is. Colby, what do you think it is?
I said 1/7 cosine of 7x.
And why did you say 1/7?
So we have to count the chain rule.
Okay, so if we were to take the derivative of sine of 7x, we would use the chain rule to multiply by 7. So we need that 1/7 there to counteract that. What's he missing?
Plus
Don't miss that. Is everyone okay with that 1/7? I know it's something we kind of talked about yesterday, but I want to make sure you know why it's there. Okay. Rebecca, if we were to take the derivative of sine of 7x, we would say that it's the cosine of 7x, but inside of 7x, so we would multiply by its derivative. Okay. Well, if I have only cosine of 7x, well then I need that 1/7 there to when they multiply, they would cancel out to be the 1 cosine of 7x. Does that make sense? Okay. Okay, write this one down. You see thetas instead of x's, nothing changes. Nothing changes.
Should there be an end parenthesis after that?
Oh, like one more, like right here?
Yeah,
Probably.
because there's one in the front.
Yeah.
Oh.
Okay, so we're taking the antiderivative with respect to theta. So what's the antiderivative of theta?
Theta X.
Theta is like your x. So that's like theta to the first.
Is that 1 x squared?
1/2 theta.
Theta squared.
Uh-huh. Yeah, if you want to do it in terms of x and then go back and erase and change them to thetas, you go for it. Okay? Now, I have minus sine of theta. Positive or negative? So the antiderivative of sine of theta is negative cosine theta. So since we have the negative sine of theta, two negatives make it positive, we have positive cosine theta. Okay? And then we have negative cosecant squared of 3 theta. Well, the antiderivative of cosecant squared would be negative cotangent. So this would turn to a positive cotangent of 3 theta. But since that 3's inside, we have to counteract with the 1/3. I'm going to write like a kindergartner, plus c.
There we go.
I ran out of room, sorry. You know when like kindergartners like start their name right here, and then they like do the next letters here? You know?
We write like first grade, I can't write it.
Last trig example.
That's weird.
You gotta go like
Okay, obviously, I hope, so maybe not obviously. Can we take the antiderivative right now? No. We are going to need to rearrange this. Since it involves trig functions, we may have to use some identities. Cosine cubed over cosine squared is just cosine. That one's fine. Plus, we have sine of v over cosine squared v. Well, what's sine over cosine? Okay. But then we would still have a cosine in the denominator. So now we have a much simpler antiderivative. Do I need to write that out?
yes, please.
Okay. So we're okay with this being cosine, right? But here we have sine over cosine squared. So I wrote cosine squared as cosine times cosine. Sine over cosine gives us tangent. 1 over cosine gives us secant. Okay? Well, now we can say, well, the antiderivative of cosine is sine. And the antiderivative of secant tangent is secant. Okay. We have 2 more rules that we want to talk about. One of them is the easiest rule. What was our easiest derivative rule? Okay, the derivative of e to the x is e to the x. The antiderivative of e to the x is e to the x. Okay? The only thing that we're going to have to be careful of when it's not just e to the x. And that's what we're going to do 2 examples where it's not just e to the x. Okay? Never forget your plus. Maybe set an alarm on your phone
I'm
for
gonna
a
walk in
few
here, I should
minutes
steal a marker and
before.
do plus C like on the first.
Oh, right when I can. So I every answer for sure. Not every question, otherwise I can't forget.
Or just put down plus
Okay.
C.
Plus C, all of
What's the antiderivative of e to a power?
E
E to a power. So the antiderivative here would be e to the negative 2x.
No.
We need to take into account that if we were to go backwards, our derivative would have to be multiplied by that negative 2 because of the chain rule. So to counteract that, we need that negative 1/2 out in front. You can check your work. If you take the derivative of this, do you get e to the negative 2x? As long as we have that negative 1/2, that would be good. Okay? Are you worried? What's worrying you? Okay, do you want to leave it like this? No. We can't leave it as a fraction. So, 5 divided by e to the 2x. 5 e to the negative 2x minus e to the x divided by e to the 2x. We subtract exponents, right? X minus 2x, negative x. Now we can take our antiderivative. Okay, same concept as we did up there. E to the negative 2x has an antiderivative of, remember our copy-paste rule, but we also need to take into account that there's a negative 2 inside. So we'll multiply by negative 1/2. Same thing here. Antiderivative of e to a power is e to a power. But we need to take into account that if we were to go backwards, we would have to multiply by negative 1. So that's going to turn this into a plus instead of a subtraction sign. Okay, one more thing to talk about. Ready? Will our power rule work for x to the negative first? Our power rule would make that go to 0, right? Would it make sense to have 1/x and then everything just disappear? Do we have a derivative that equals 1/x? So the one other thing you need to be on the lookout for is if you have 1/x, which is the same thing as x to the negative first, its antiderivative would be the natural log of the absolute value of c. Sorry, okay, sorry. I made it a point to say absolute value and then I didn't say x. Okay? Why do we need an absolute value? Okay? If we have 1 over x, x could be anything except probably one number, right? Well, we can only have positive values inside of a logarithm, and so we're going to have to put the absolute value bars to make sure that that will happen. Okay? So if you see, like this, the antiderivative of 7 over x, so what? I would encourage you to think of this as 7 times 1 over x, which would be 7 times the natural log of the absolute value of x plus c. What? In the denominator? Andre's worried about 7 over x squared dx. But let's process it. What's different about this? What would we use for this? The power rule. This is 7 x to the negative second. So we would have negative 7 x to the negative first plus c. That is absolutely something we should talk about. Why are you upset about that? You are not the only person thinking about
I
it.
think it's funny.
You are not the only person worried about that. It's good to point that out. Okay, as long as our denominator is linear, linear means what? So x to the first, looks like a line. As long as our denominator is linear, we can use this rule. This antiderivative is just the natural log of the absolute value of x minus 5 plus c. As long as it's just 1 over a linear function, then you're okay. Anything else we're going to get a little crazy with, but as long as it's just that, we're okay. Okay. In preparation for your quiz, so you have a worksheet with some book problems that you can just put on the back of it. Okay? Now, we didn't talk about 6 through 10 on the very top of this worksheet, so cross them out. The 2 to the x, 3 to the x, we didn't talk about those. I don't want to talk about them right now. Is anyone going to see this?
Until Monday.
She's sick.
No, Thursday is like.
If you want to even do like 12, here's how I'm going to do all of what? If you want to do text. Oh, don't stop that one more. And it's like somebody at 10
Just like it's one to myself.
Okay, we have 3 minutes. Do 1 through 5. Oh. 1 through 5. Super quick to do. Why would you do that?
I don't know.
I should just. They're just like me saying.
I don't know.
Someone's gonna be really awkward. I got People figure that out. Look like you're really mad. I can't find one. This could be real hard. Oh, well, the time is yours. Finding it.
It's like,
Oh,